Hello, welcome to some background information so that we can solve some trigonometric equations. The first you will see is the unit circle. Yes, you need to memorize the unit circle. I will give you blank copies always, but you need to know the different values. Just as a slight little recap on it, remember you clearly have your degrees. You have your radians on the outside. When you're looking at these values, this is the x value is your cosine, because remember cosine deals with left to right position, and your y values are your sine values at different angles. Therefore, if you wanted to come up with your tangent, remember tangent is sine over cosine, so you could do 1/2 is your cosine, so it's on the denominator, and then you have root 3 over 2 as your numerator. When you write it sideways, you get square root of 3 divided by 1/2, and then now you're going to multiply by the reciprocal. So you're going to change that to a times 2 over 1. Then you get square root of 3 over 1, which is the square root of 3. And that would be the tangent value for this angle. Please remember that those 2's will always cancel out when you multiply by the reciprocal. So you could just do the numerator square root of 3 over 1. This one would be the square root of 2 over the square root of 2, which is 1. So that's just a quick trick. Now we're going to be solving trigonometric equations this week, but first we have to review some old things for solving equations. For example, when I have x squared equals 9, how do I solve that? Well, I take the square root of each side, and then x equals plus or minus 3. Don't forget your plus or minus when square rooting both sides. That's because positive 3 times positive 3 equals 9, and negative 3 times negative 3 equals 9. That's why there are two answers. Now, if our equation is set up like this, this is already factored. I don't need to distribute. I can go back to my fireworks experience, and I can set each factor equal to 0. Now I have two answers. I have x equals 0, clearly, and I have x equals negative 3, because I set both equal to 0 and solved. So in this case, I would set this parenthesis equal to 0, and I would set this parenthesis equal to 0. I solve, and I get x equals negative 3 and positive 4, and those would be my two answers. This one I cannot solve unless I use the quadratic formula, which you're more than welcome to use. However, what I will do is I will factor it and then solve, because I actually enjoy factoring. So remember the x squared top quadrant, this is a trinomial, so this should be very easy at this point. Negative 5 and a positive 2 will make it so I get negative 5x plus 2x, which equals negative 3x. So my answer is x plus 2 and x minus 5. That's really bad. When I set that equal to 0, and I set each piece equal to 0, I get x equals negative 2 and x equals 5. If you had chosen to use a quadratic formula for this, you would have gotten the same answer. So for this one, I do need to also factor it, but the first thing I need to do is subtract 2 from each side. You cannot factor it when solving unless it is set equal to 0. So I'd subtract 2 and I get negative 12. When making my area model, I think when I make a thinner line it's easier to draw. When I make my area model, I need to remember this is 2x squared. So it's going to be a little different than x and x. And this is going to be negative 12. 2x, x. Now I need to, what numbers are going to multiply? I'm going to try 3 and I'm going to try 4. This would give me 8x and this would give me 3x. So I need this to be a negative to make it positive 5x. So in factored form, I have 2x minus 3. And I have x plus 4. And we're going to set that equal to 0. Then I'm going to set each piece equal to 0. So I have 2x minus 3 equals 0. And I have x minus 4 equals 0. X plus 4, sorry. Jumping ahead of myself. When I'm solving this, I make 2x equal 3. I divide both sides by 2 because I added 3 to each side, remember that. So x equals 3 halves. I'm trying to mouse instead. That'll be the clicking in the background. And then I solve this equation and I get x equals negative 4. And now I have two answers. Just as a necessary trig recap, remember secant and cosine go together, cosecant and sine go together. Therefore, if the secant is 2, cosine is 1/2. If cosecant is 3, the sine is 1/3. They're reciprocals. Sine of 30 equals the sine of 390. Why? Here, the sine value of 30 is right here. Let's highlight it. Why is that the same as 390? Well, 390 is a full circle, 360 plus another 30. So they give you the same measure. Well, what else has the same measure of that? Well, let's add another 360. So that would be 750. 360, 720, 750 has the same measure as 30 degrees. So therefore 30 degrees repeats every 360 degrees, or if I'm in radians, that would be every 2 pi radians. Oftentimes when we're solving trig equations, we actually like radians more than degrees. So let's take a look at that. Sine of pi thirds is also equal to the sine of what angle? So here's the sine of pi thirds. Sine of pi thirds is the same as the sine of 2 pi thirds over here. And it's also the same as if I went a full 2 pi plus another pi thirds. It'd be the same as going 2 full circles, another pi thirds, 3 full circles, another pi thirds. So I say that the sine of pi over 3 is the same as the sine of pi over 3 plus 2 pi n. Therefore, that says I can make n1, that's 1 full circle plus pi thirds, 2 full circles plus pi thirds, 3 full circles, etc. Similarly here, it's plus 2 pi n. Now let's take a look at the cosine. Cosine of pi halves, we're looking at the x values. Oops, so I'm going to erase instead of draw more circles everywhere. So pi halves is right here. The cosine value, the left-right position, is also here. That does not, this repeats every pi. Notice how every pi, it's a new answer. It's a new answer every pi. So this value repeats every pi n. Okay? So you have to think about when something repeats and when it does not. So, for instance, the tangent, let's take a look at the tangent just randomly. The tangent of pi fourths, when does that repeat? Well, the tangent at pi fourths happens to be 1, positive 1. Where else is tangent positive? That's in the third quadrant, happens to be right here. So notice that repeats every pi n. So it'd be pi over 4 plus pi n. That's when those tangent values are the same. Hint, sine and cosines tend to be 2 pi n, tend to be, but again there are exceptions, and tangents tend to be every pi n. That's it for our background information.